Hello, I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator on Relevel. So let's continue our discussion where in the last video we already talked about the concept of process state wherein we talked about how does a process moves from one state to another state. So now in this video, we are going to continue that discussion and talk about the very next topic, which will be process control block. Okay, so what happens is whenever you have a process which is created, for each process, we have a process control block. Okay, that basically has all the information about the process. Okay, the other name that we use for process control block is known as task control block. Okay, it is a data structure which basically contains a lot of, I would say, components along with it. Okay, so you can say that a process control block is basically a data structure, okay, that is maintained by the operating system for every process. So it's like a one-to-one mapping. For every process, you are going to have a process control block and the operating system maintains that process control block. Okay, a process control block basically keeps all the information that is required to keep track of the process. Okay, and what are all the component it has a pointer, it has process state. Inside a process control block you store the process number as well as you store the program counter, as well as you store registers information, memory limits, list of open files, and some more components as well. But the one we mentioned over here are the ones which are the most important. Okay, so let's quickly go ahead and take a look at what exactly all of these components are inside a process control block. So whenever we talk about process state, we have already taken a discussion about the states of a process, right? That whenever we are executing in a process, there are 5 possible states and your process always has to be in one of state, the waiting state, new state, right? Ready state, any state is possible. Okay, so always and always in process control block over here, we maintain the state of the process. Along with that, we have process ID as well. Okay, what is process ID? Process ID is basically a unique identification for each process in the operating system. So in your CPU, there might be a lot of processes that we are trying to execute, right? So we need to make sure that we are uniquely able to identify each and every process. So we do that with the process ID. Okay. Now, along with that, what we also store over here is, privileges, or I can say process privileges, as in what all resources the particular process or what all system resources the particular process is allowed or not allowed to access. Okay. So we have discussed about process state, we've discussed about process ID, and we've talked about process privileges. Along with that, we also store the information about CPU registers and program counter. Okay, CPU registers. So we have a lot of CPU registers, right? CPU registers are a way, right? It's basically a memory space that is available. So CPU registers are available where different processes needs to be stored for the execution for the running state. So whenever you have a process, right, that is being executed, right, it's in the running state, it's always not in the primary memory but in the registers. Okay, so registers are small space, memory space itself, right, where your processes are stored whenever they are executed. Okay, and when we talk about program counter, so program counter basically holds the address of the next instruction to be executed for that process. So what I told you in the start was that program is nothing but a set of instructions, right? And a program, when it is executed, it becomes a process, right? When a program is loaded into main memory, it becomes a process, and process executes all those instructions step by step in a sequential manner. So whenever you are executing an instruction, you also need to know where the next instruction is stored. So program counter basically stores the address of the next instruction which needs to be executed after the current instruction. Okay. Along with that, we also have CPU scheduling information. Okay, it basically stores such as priority information and pointers to the scheduling queues. Okay, so what happens is some processes in the system are priority processes which needs to be processed or executed before the usual flow of the processes in the queue that we have. So we have processes priority and other scheduling information present as well, which is used to schedule a process. So all of this is present in CPU, or all of it is known as CPU scheduling information. Don't worry if it doesn't make a lot of sense right now. In future, in the next slides, we are going to discuss in detail what is scheduling and what is CPU scheduling for processes. Okay. Next, what we have is the memory management information. Okay, for example, page table and segment tables. So what happens is in memory management, we basically store information of page tables, memory limits, segment table, depending on the memory that is being used by the operating system. So for understanding this topic in detail, right, and all these aspects, there is a separate module on memory management. So you can refer that module where everything about memory limits, page table, segment table, everything has been covered in detail, so you can check that out as well. Then we have accounting information. So this basically includes the amount of CPU, right, which is basically used for the execution of a process, and also along with that execution ID, account numbers, CPU kernel time consumed, etc. Okay, so all this accounting information, as in how much resources did you use, for how long did you use, right? What is the execution ID? All of these information is present as a part of accounting information. Then we also have IO status information. So this basically includes all the input output devices that are allocated to the process. Okay, so we saw that a process can require external interruption or external input output computation as well, right? So in that case, the input output status information as a part of process control block basically stores all the information about what all devices, input output devices, were allocated to that particular process which is being executed. So this basically forms the entire picture about what is a process control block. Just to reiterate and quickly, remember what all we have discussed. So process control block is maintained by the operating system for each and every process that is supposed to be executed. Okay, so it's a data structure which contains useful information about a process, and it basically helps us to keep track of each and every process which is supposed to be executed. It basically contains a lot of components inside it. Some of the components are state of the process, which can be running, waiting, terminated, new, ready. We also have a process ID, which is a unique identifier for that ID. In processes, we can have a parent process. From a process, we can originate child processes as well. So if there's a parent process, we basically store the information about the parent process as well. CPU registers and program counters. So whenever you have to execute a process, you basically load it in the registers, right? So basically, we have a lot of CPU registers. So all those information about those CPU registers used to execute the process is stored over here. And program counter basically holds the address of the next instruction to be executed. So we hold the information of that address as well. Sometimes in the processes execution, there are some priority processes as well. So the information about those priority processes and the scheduling queues is stored in the CPU scheduling information. Whenever you are using processes, we have a lot of usage of segment tables, page tables, memory limits, time limits. So all that information goes under memory management information. Along with that, when you're executing a process, you also store information about how much resources that the CPU took up, right? What are the maximum time it basically took up? What are the account numbers? So all that information goes into accounting information. And the last one is that whenever you're executing a process, what all external input output devices got allocated to your process is basically stored over here. So this forms our information about process control block. So now we have a good, I would say good enough knowledge to understand what exactly is a process and what exactly is a program. So we'll take a diagrammatical differential view about the differences between both of them. So when we talk about process, the process is basically an instance of the computer program that is being executed. So a computer program that is being executed becomes a process, whereas a program is nothing but a collection of informations, okay, that basically have a certain informations present inside a program. It's an executable file which has a set of instructions, and if you complete those instructions, you are able to perform a specific task for the computer. Okay. A process basically has a shorter lifetime because you try to execute it as much as early as possible, whereas a program has a longer lifetime. Till the time you do not execute a program, it still remains a program and not a process. Now, a process is basically a program in executing, a program in execution. So if you are executing a program, you would require resources as memory, CPU, input-output devices. Whereas your program is not stored in main memory, it is stored in secondary memory or a hard disk, and it does not require any resources because it's just an executable file. We're not yet executing it, hence we do not require any resources, and hence we also store it in the secondary memory. A process has dynamic code and data, right? And along with that, when we come to program, a program has a static code and a static data. Okay. Now, when we come to processes, basically a process is a running instance of a code. So you have a code and you're actually creating an instance of it and running it. So that is why a process is a running instance. Whereas on the other hand, the program is the executable code. If you remember the very basic example we took in the start, that whenever you have a Chrome, right, or a notepad, you always had notepad.exe, which is an executable file, which is known as a program because it has a set of instructions on how to view web pages on the internet when it comes to chrome.exe. And we also have notepad.exe, which contains steps or instructions on how to create, edit, and print the text file. So this forms a major difference between what is a process and what is a program. Now, the last thing that we will talk about is process scheduling. Okay, like I told you in the very start itself, that if you have multiple processes, right, and you do have multiple processes, right, which wants to be executive because you want to do a lot of tasks parallelly. So the idea is that when there are two or more runnable processes, that is decided, then so if you have a single process, then the operating system has no choice but to run that process. But if you have two or more than two runnable processes, then it is decided by the operating system which one to run first. Okay, and that process of scheduling the processes by the operating system is known as the concept of process scheduling, right? So you have a lot of processes, and now the operating system is to decide which process to run first and which process to run later than that. So you have to schedule the processes in a certain manner, and this concept is known as the concept of process scheduling. Now, a scheduler is basically used, so operating system have schedulers. Those schedulers are used to decide which programs to run first and which programs to run later based on a scheduling algorithm. So we usually pick a scheduling algorithm, and based on that we decide which processes needs to be executed. Now, since we are talking about scheduling algorithms, before actually jumping on to which scheduling algorithms are available, we should know and talk about what is the property of a good scheduling algorithm. So here, the properties of a good scheduling algorithm would be where the response time should be minimum for the users, right? Wherein you can process or you can execute a process as early as possible and provide the response to the users. Okay, the number of jobs processed per hour should be maximum. Okay, that is, the good scheduling algorithm should give maximum throughput. So it's like if you have to execute multiple processes, that means you do have a lot of tasks that needs to be done. You have a lot of jobs that needs to be done. So you want to make sure that your operating system is maximum occupied throughout the duration, right? You don't want your operating system to sit idle, whereas you have a lot of jobs to be executed. So the concept of throughput is how much is the CPU or the operating system is being used when you have multiple jobs or multiple tasks inside a process to be executed. Okay, so a good scheduling algorithm always makes sure that the throughput is maximum, that you're utilizing the operating system as much as you can. And in the next point is just the corollary of the previous point, that the utilization of the CPU should be 100%. If you have a lot of tasks, you have to make sure that the CPU is being used to its utmost capacity. The last one is that each process should get a fair share of the CPU. So if you have multiple processes, think of it like that. Multiple processes are competing against each other in order to actually get to use the CPU, right? All of them are competing and all of them are competing against each other as to get the allocation of the CPU so that they can execute their task. But the thing is, we have to make sure that the algorithm that we choose for scheduling is fair, because if it's an unfair algorithm, what it would do is it would favor a particular process and allocate resources to that process as in the most or allocate resources to it most of the time, whereas there could be multiple processes which do not get any share altogether when they are trying to get hold of the CPU. So you have to make sure that there is a fair division of a CPU between all these processes. Okay, now the act of determining which process is in the ready state and should be moved to the running state is known as process scheduling. So like I told you, all the processes, or there are a lot of processes which are trying to get hold of the CPU resources. So till the time you do not have hold of the CPU, you are in the ready state. And if there are a lot of tasks, there are going to be a lot of processes in the ready state. So what we do in process scheduling is we pick a process, we make it from the ready state to the running state. Okay, so this act of determining, this algorithm that we design for determining which process should go from ready state to the running state is known as the concept of process scheduling. Okay, the prime aim of the concept of process scheduling system is to keep the CPU busy all the time. The reason why we have devised algorithm, the reason why this kind of a systematic representation and deep discussion for process scheduling is required is because you want to make sure that your CPU is utilized. Because if your CPU is not utilized and there are a lot of processes that aims to execute, you will have a lot of delay in responses. Okay, so the very aim why this entire process of scheduling is designed so that you can use the CPU to its utmost capacity and to deliver the response to the user for all the programs in the minimum time possible. Okay, it should not be like for a particular process it's taking hours and hours to give the response. You want to keep the response time as minimum as possible in order to ensure good customer experience. And now for achieving this, scheduler basically apply appropriate rules for swapping processes in and out of CPU. So what happens is when you have multiple processes, it's not like the first process will come, it will execute fully, it will go to termination state, then we pick another process, it will go from ready state to running state, it will complete its running state, and then it will go to termination state. So it doesn't work like that. What you do is you take a process P1, you take it from ready state to running state, you execute it for some time, you put it back into the ready state, okay, and then you pick another process. So it's like a parallel thing going on over here. To show you all like a very layman, in layman terms, to show you all a quick example for this, it would be something like this. So if you have process P1, P2, P3 and P4 and all are in the ready state, it's not like first P1 will fully get executed by the CPU, then P2 will fully get executed by the CPU, then P3 and P4. It doesn't work like that, because that means the process in the end will have to wait a very long time. To give the notion that everything is executed parallelly, what you do is you execute it for some time, then you execute P3, P2 for some time, then you give it to P3, then let's say you start P1 again, and then you start P4, okay, and then you have this, okay, and then you have this. So you kind of swap processes in and out. So you first take the process P1 from ready state to running state, then you put it back into the ready state, and you pick the process P2, you put it into running state, and then you put back into ready state, then you pick the process P3 and so on. So the idea is you keep on swapping the processes in and out of the CPU. Sometimes for some period of time, you give it to some particular process, then you basically take the processes or the resources back and you give it to other process. Okay, so that's what the entire concept of process scheduling is. And trust me, it is extremely important to have a good knowledge of how this idea works. So now what we're going to do is, in the next video, we'll first start our discussion with scheduling queues. We have talked a lot about the process of, like the idea of process scheduling, right? And why do we really require that? And what are the good properties of a good scheduling algorithm? In the next video, we'll talk about what are the properties or what is a scheduling queue, right? And how do we really work with that? And then we'll take a good diagrammatical representation of that, and then we will move on simply to different schedulers that we have available. Okay, so these are more or less different algorithms which are available for scheduling a particular task, okay, or a particular process. All right, so stay tuned in for the next videos as well, and we'll be very soon coming up with the next video and talk about the process of scheduling queues. All right, thank you.